second video on the analysis of variance. If you've not yet watched the first video, please go back and watch that first. It's going to provide critical foundational knowledge for you to understand the topics that we're covering in this particular video. So just a real quick recap of what the previous video discussed is that ANOVA partitions variability into two different aspects of our data, and that's the differences among the different groups, and also the differences within the respective groups. So how much variability is there in the data across our treatments and within our respective treatments in order to test the null hypothesis that our means are all the same. If we tend to get greater differences among the groups, then we have less support for our null hypothesis, greater chance of rejecting it. If we've got greater differences within the respective groups, then we've got increased support for the null hypothesis. So in order to discern if we should reject or support our null hypothesis, we're going to use an F value similar to our F test, but the data that goes into this particular calculation is going to be a bit different. And our F value is going to be based on our among group variance divided by our within group variance. So we're looking at different variances here, but they're going to come from different respective locations. Similar to the F test, we're also going to use our F table. So again, just as a reminder, these interior portions of the table are critical values that we'll need to exceed in which to reject our null hypothesis. The first row here are our degrees of freedom for the sample with the larger variance versus the sample with the smaller variance. That was for the F test. We're going to make some changes here with these respective degrees of freedom. These are still going to be for the numerator and for the denominator, but rather than based on which variance is larger or smaller, we're basing this on our among group variance and our within group variance. So it's still going to be the numerator and the denominator for our respective F value, but we're changing things up a little bit. And we'll go through class and we'll do practice problems in which to make sure everybody feels comfortable with this, but this is an important distinction to make. And these degrees of freedom are going to vary for the numerator and the denominator. Previously for the F test, it was just n minus 1 for each of our populations. For this particular case, for ANOVA, the numerator, the degrees of freedom are going to be the number of groups minus 1, and for the denominator, it's going to be the total number of observations across our entire study minus the number of groups that we have. So let's think about our scenario that we discussed in the previous video. We've got our different base systems. We're looking at the size of red drum across these base systems, and we've got our distinct distribution curves for each one of those base systems. Well, if it is that our variability within each of these base systems is relatively small, and the variability across these base systems is quite large, well then it's likely that our among group variance is going to be larger than our within group variance. And so as the value for F increases, we're going to have a greater likelihood of exceeding our critical value, and in turn we're going to have a greater likelihood of rejecting the null hypothesis that these bays are the same. And it's going to suggest that this particular factor of interest, bay, has an important effect on the size of our red drum. But if we think about one of the other scenarios in which there's quite a bit of variability within these respective groups, our within group variance is quite large, well then our F value is going to decrease because our denominator is getting larger. And this is going to reduce the likelihood that we're going to exceed the critical value, and in turn we may not reject the null hypothesis and infer that the factor of interest bay has little effect on the size of the fish that we're measuring. So for this analysis of variance, we're partitioning the variability into among and within groups, and we're going to do so based on the sum of squares. So this goes back to our discussions on dispersion and on variance, and so we're seeing the connectivity we have across our topics. So we have three different sum of squares that we need to take interest in for analysis of variance. The first of which is the total sum of squares, so this is for all the data, and then we have our sum of squares for among groups and our sum of squares for within groups, because we're interested in the variance of these two components. And the sum of the among group sum of squares and the within group sum of squares equals the total sum of squares. And we're going to talk about how we can take advantage of this when we're using analysis of variance to test across different populations. But how do we actually partition the variance from our raw data and get to a point where we have a test statistic to test against our critical value in this table? Well, we're going to discuss this using Excel, and we're going to go through a series of steps that illustrate how to actually go about doing this. Okay, so we have our respective data here for our different base systems and the fish from those respective base systems. So we're going to go through a stepwise progression of how to actually calculate the F test statistic for our analysis of variance and then compare that to our critical value. Now, something important to note is that we're going to go through some steps that you're not going to be responsible for knowing for this particular course, but again, it's going to be important background information in general for you to understand how we get from our raw data to the actual F value. So we have our respective data, and the first step for this ANOVA is going to be to take the summation of each one of our respective levels or groups and then take the sum of those sums. And so here we can see in our formula we have the summation of our respective values for each one of our respective bays, and then we've got the summation of those respective bays. Our next step is going to be to square each one of the values that we have for our respective data and then to take the summation of the bays. So this would involve squaring each one of our data values and then taking the summation. And then again, we'll take the summation of these sum of squared values. Our next step is going to be to take the summation of our values, to square it, and then divide it by our respective sample sizes for each one of our base systems. And then again, we're going to take the summation of these. And so we're taking our respective sum of our values, we're squaring it, and then we're dividing it by our sample size. And then here again, we're taking the summation of our respective values. Following this, we're going to then need to incorporate the group numbers into our data set in which to start calculating out some values that we'll use to determine what our sum of squares of the total, sum of squares within groups, and sum of squares of among groups are. Once we start doing this, we're going to follow a series of steps. Now, we're not going to cover this in this video because you're not going to be responsible for doing this, but I will put the Excel spreadsheet on eCampus so that way you can go through and look at this and see how these values are calculated if you're interested. But the sum of squares total is calculated by taking the second step here where we've taken the summation of the squared sums, and we're going to subtract out this new value here in which we're incorporating out the groups. We then can calculate out our among groups sum of squares by taking the summation of our sum squared divided by our sample size and subtracting out again this group component that we're taking account. And then based on our understanding that the sum of squares total equals the among group sum of squares plus the within group sum of squares, we can just do some basic math in which we are subtracting out the among group sum of squares from the total sum of squares. Now again, these 7 steps are not going to be something you're responsible for in this particular course, but it provides the foundation to understand how we get to the next step, which you will be responsible for. So once you have an understanding of what the total sum of squares, among group sum of squares, and within group sum of squares are, you can then start populating this table here on the right. And this table is what we're going to use in which to calculate our test statistic of F. So now that we have our sum of squares, we can populate the table with these values. And as a good double check, the summation of the among groups and within group sum of squares should equal our total sum of squares. Next, we need to know what our degrees of freedom are. Now, as we covered in the lecture, our among groups degrees of freedom are going to be the number of groups minus 1. In this case, we have 3 different base systems, so it'll be 3 minus 1. Our within groups degrees of freedom are going to be the total number of observations minus the number of groups. So in this case, we have 15 observations, and we have 3 groups. So this will be 15 minus 3, which will be 12. And then our total degrees of freedom will be the summation of our among groups and our within groups degrees of freedom. So once we have this information here, our sum of squares and our degrees of freedom, we can then go through and calculate out the necessary values in which to determine what our f value is. Our next step is going to be to calculate out what the mean sum of squares is, and we're going to take our sum of squares and divide these by the degrees of freedom. And we're only doing so for the among group source of variance and the within groups source of variance. So we can go through, we get our sum of squares for among groups divided by our degrees of freedom, and we can get our respective mean sum of squares value. We can do the same for our within group sum of squares, taking the sum of squares dividing by our degrees of freedom and getting the mean sum of squares within groups. And then our f value is simply the ratio of these two. Again, our among group variance and our within group variance. So we do that, and we can then calculate out our respective f value. Now that we have our f value, we can then take this and compare this to our f table. So we can then look at our f table, and again, our numerator and our denominator are not based on the size of the variance for each one of our samples. It's going to be based on our table. So the numerator is going to be our among groups. So we're going to use the degrees of freedom for our among groups here for our numerator, and then we're going to use the degrees of freedom for our within groups for the denominator. And so in turn, we can go to our table, we can find 2 for the numerator and 12 for the denominator, and find what our critical value is here for alpha equals 0.05. It's 3.89. We then compare our respective f value to this, and what we notice is that our f value exceeds that critical value. And so we can then discern from this is that there is a significant difference across our respective bays, in that because our f value exceeded this critical value, we then can say that there's some type of difference in the size of red drum across different estuaries in Texas. Now we moved through this relatively quickly, but you're going to have this spreadsheet in which to work through this example on your own, and we'll be covering several examples in class to make sure everyone's on the same page. As we've seen, we can go from having raw data on our different bay systems to discern if there is some kind of difference in the size of our fish in those respective bay systems. Now, as I mentioned in the recording, you're not going to need to know how to do all of these steps, but having a foundational understanding is important when you are deciding on the inference that you're making from the statistics that you are gathering and calculating. And so I'd strongly encourage you to go to section 11.1 and section 11.2 and section 11.3 of the text in order to reinforce these concepts that we just discussed. Now in class, what's going to happen is that you'll be provided with some of the information that you need in which to calculate this f value. You won't be given everything, but you'll be given some of the information, and you'll need to fill in the rest. And we can use the structure of the analysis of variance to our advantage in which to then fill in the information that we are unfamiliar with. So the first concept that we can use is that the among group sum of squares and the within group sum of squares equal the total sum of squares when we add them together. So if we know one, we can then calculate out the others. Also, we can use the advantage that the total degrees of freedom equals the degrees of freedom among groups plus the degrees of freedom within groups. So again, if we know 2 of these, we can figure out what the third is. And we'll be doing more practice in class, but in general, what's important to note is that if you are given some of this information, you will need to be able to calculate the mean sum of squares, the f value, and then determine if that f value is significant or not. And for practice, I'd suggest going to the book and working through some of the practice exercises and going back to the text and making sure that you understand these concepts. Moving forward, we're going to now, in the next lecture, decide once we have identified that there is a difference from at least one of the means from the others, how do we decide which of those means is different from the other from a statistical standpoint?